All right. Luckily, for the people that were absent, the warm up today is similar to what we did yesterday. So if you were absent, you have another shot at it. Okay. So there are two skills here. You see this V. As soon as you see that the graph is like a V, you should know what kind of functions turn out to be a V when you graph them. Absolute value ones. So one thing I should be able to do is look at that function and write an absolute value function for it. So let's do that. Let's see. Looking at the right-hand part of this graph, well, you know what? Let's start with the vertex. The vertex of problem number 1 is right here. Can you tell me, what is this vertex anyway? 3, -6. Okay? That should tell me a lot about this function. What's going to be on the inside of this absolute value symbol? X minus 3. It's always the opposite of the x. What's going to be on the outside? Right, just -6, -6. All right, the y value of the vertex just stays exactly the same. Now, do I need to put anything in the front of this absolute value? It's all about the slope. Look at the slope of the right-hand branch. Okay, let's see, I was told 1/3 because it seems to go, wait, how many up, how many right? Maybe it's, you know what, I think it's, let's see. It's a little bit hard to see, but yeah, look at these dots. Put some dots on your paper to see if you can see exactly where it's hitting the line. It seems to be going up 4, right 1, up 4, right 1, up 4, right 1. So I'm going to put a 4 in the front of this because of that, 4/1. Now, so that would be the absolute value function for this graph. But we also could write this as a piecewise function. And this is what we were working on yesterday. Let's see. First, I'm going to write the function for the left side of this picture. Okay? So I'm about to write the function for this half of the graph. So, I need the slope and the y-intercept. Well, we just counted the slope on this side. It was up 4/1. That means the other side would have to be the same, only negative. So if the right side had a +4 slope, the left side is going to have a -4 slope. So that's -4x. And then I need the y-intercept. What's the y-intercept of this line? All right, that seems to be the y-intercept right there. 1, 2, 3, 4, 5, 6. So -4x plus 6. Okay? That's the little equation for the left side of the line. Yes? The slope. Look at the right-hand side that I'm going to get to in a second. Remember when we were counting the dots and we saw that it goes up 4/1, up 4/1? That told us that the slope on this side was +4, right? So when I write the equation for that side, it's going to be like +4x, right? These slopes are always going to be the same, except for one's positive and one's negative. So if this is +4, then the other one has to be -4. Okay, if I made dots and stuff, you would see that it went down 4/1. Okay, so that's the equation for the red part of the graph. But we also need that part that says if x is less than something. I'm saying less than because this is the left part of the graph, the left side. But what is the x value where the graph changes from one branch to the other? 3. Look at the x value of the vertex to help you out. Okay, the x value of my vertex there. This is the place where it switches from the left branch And then boom, and then it becomes the right branch at an x value of 3. So for x values that are less than 3, that's when it's going to be the red branch. Okay? Did I lose anybody on that half of the problem? Now the right half of the problem. Again, if the left half had a slope of negative 4x, let me pick a color for this. I think I will do blue. Okay, so now I'm going to do this blue part of the graph that I'm coloring blue right now. Okay, so if the left side of the graph is negative 4x, the right half of the graph is going to be positive 4x. So positive 4x. Now I need the y-intercept. Okay, it is not obvious what the y-intercept is, so please watch this very carefully. Normally what I would do is I would extend this line out further and see where it hits the y-axis. Why is that going to be a little bit tricky on this problem? Yeah, the graph, I run out of graph paper. If I go down 4 over 1, that gets me to here so far. Now, you could probably still figure it out, even if you're just sort of going off the graph. I'd have to go down 4 more, down 4 more. But this is how I'm going to do it. I'm just going to do y equals mx plus b to figure out what the y-intercept is on this side. Okay? Watch how I can find this b value. Let me do this off to the side. Y equals mx plus b, you guys. Okay, focus on the blue side of the graph. Do you remember what the slope is for the blue side? What's the slope on the blue side? The slope is 4. Okay? Now, I'm going to use the vertex. Just use the vertex. Why not? The vertex gives me an x value and a y value. So as I do my y equals mx plus b, I'm going to use my vertex for an x and a y, and I'm going to use my slope for the m. Okay, so you can see I can just plug in everything except for the b, and I should be able to find the b. So this is going to give me negative 6 equals 4 times 3 plus b. That means negative 6 equals 12 plus b. Subtracting that 12 from both sides gives me b equals negative 18. So that means the b value is negative 18. So boom. For me, that's the best way to get it when it goes off the graph and it's hard to see. Just plug everything into y equals mx plus b and find your b that way. It only takes like 15 seconds. I still need the if part. If x is greater than or equal to 3. Now, for people that were here yesterday and paying attention to the video, can anyone tell me how did I know which one of these to make or equal to and which one just to leave it as less than? It doesn't matter. You just pick one. I always let the first one just be less than, and I make the second one be or equal to. Just pick one. Just make it one of each. It doesn't matter. So that's how you do it, and that's what we learned yesterday. Okay. Number 2, just more practice of the. Oh wait, domain and range. I almost forgot. What's the domain of this problem? Negative infinity to positive infinity. What's the range for this problem?
Negative 6, positive infinity.
Negative 6 to positive infinity. Any questions on the domain and range? Okay. Look, as long as we're rolling on domain and range. What's the domain and range for this next problem? Still negative infinity to positive infinity. What about the range? Let's see. Negative infinity, because we got to go from the bottom to the top. 8. Negative infinity to 8. Any questions on where these domain and range are coming from? Okay. All right. What's the vertex of this function? That's going to help me write the absolute value equation. Count on your paper. Tell me what the vertex is.
7,8.
7,8.
Yeah.
Okay, the vertex is 7,8. That should help me write most of the absolute value function. What goes inside the absolute value?
7.
X minus 7. Okay, it's always the opposite of the x. What goes on the outside of the function?
8.
Plus 8. Okay, that gives me most of the absolute value function, correct? Do I need a number in the front this time?
Yes.
I do. Is that number going to be negative or positive, you guys?
Negative.
Negative. Notice how the graph is upside down. It's an upside down V. Right away that tells you it's going to be negative something. So let's put that negative there right now. Then it's just a matter of what's the slope.
3.
Seems to be going down 3 over 1. Down 3 over 1. So that's just negative 3. Okay, so there's my absolute value function. Okay, but we also need to write it as a piecewise. So once again, okay, I have my blue side over here. And then I'm going to have my red side over here. Okay, let's do the red side first. I need basically y equals mx plus b, you guys. So the slope. What's the slope of the red side? It's 3, right? The blue side had a slope of negative 3, so the red side must be positive 3. Notice that the red side is uphill, so I know it's going to be positive, up 3 over 1. So that means 3x so far, 3x. Now all I need is the y-intercept.
13.
Now, yeah, this one you could probably do in your head because it's so close to the line. You know if I go down 3 over 1 one more time, you know what I mean? It's going to land. If I go down 3 one more time, it's going to hit down 3. So this is like negative 10. The edge of my graph is at negative 10. So this is going to be negative 13. Okay, so you could probably just kind of add a few extra lines and make it. Okay, but just for practice, one more time I want to demonstrate the using y equals mx plus b to do it. So one more time, watch how I do it. Y equals mx plus b. I'm going to plug in everything except for b. Where do I get my x and y from? Vertex, you guys. Remember the vertex was 7, 8? So I can use 7 and 8. So that means 8 equals. Now I'm doing the red side. So the slope is positive 3 because it's the red side. And then x is 7. Okay? That means I have 8 equals 21 plus b. Subtract 21. So in my calculator, what's 8 minus 21? Negative 13. So that gives me that b is negative 13. So that's another way you could figure out this negative 13. All right? It's not too hard. I need the if part. If x is less than something. How do I get this number, the cutoff number? It's like the x value of the vertex. You could think of it as the axis of symmetry. If I put a vertical line right here, that shows you where this graph gets split into 2 parts. Okay, see that green line I just put? That green line is where it splits the graph between the red and the blue. That green line is at a value of 7. Okay, that's why we always use the x value of the vertex. Okay, so that's why I'm going to say if x is less than 7. Now let's switch over to the blue line. If the red line had a slope of positive 3x, the blue line will have a slope of negative 3x. They're always opposite. Now all I need is the y-intercept. Okay. To find the y-intercept, this goes way off the graph. The y-intercept of this goes way off the graph. So let's use our y equals mx plus b trick. I'll just do it down here. So here we go. Y equals mx plus b. Okay. Once again, I'm going to use my vertex. So y is 8. The only difference is instead of using a positive 3, this time the slope is negative 3 times 7 plus b. So that gives me 8 equals negative 21 plus b. If I add 21 to both sides, that gives me b equals, that's 29. So b is 29. So that's going to be negative 3x plus 29. Okay? So if you can't see your y-intercept, just use y equals mx plus b. Plug in the vertex and the slope, get your b. If, can you tell me what I'm going to write next to finish this off?
X greater than or equal to 7.
X is greater than or equal to 7. Do you guys understand where I'm getting the 7 from at the end? Calvin, do you understand where I'm getting the 7 from? Okay. Any questions before I move on to the other work? Okay. And this is all review. I'm going to do this pretty fast because hopefully you already did it in the whole time while I was handing out papers and you had to wait. So I'm just going to do it kind of fast, okay? Graphing this, I'm going to start with the left side like I always do. Well, I guess this is actually the right side. This is y equals negative x. So I'm about to graph this. Y equals negative x. Well, that gives me a y-intercept of 0 because there's nothing on the end of it, so that's a 0. The slope is negative 1. So that's like down 1 over 1. So here I go, down 1 over 1 like this. All right, hopefully you're doing this in pencil because we're going to have to erase some dots later. Okay, those dots show me where the first branch lies. But I'm not going to draw in the entire branch, am I? What part of this line am I going to draw in? How do I know where to cut this off, you guys?
5.
Yeah. All right, you guys are scaring me a little bit. These numbers on the end tell me what the cutoff x value is. Part of the graph is going to be greater than 5. Part of the graph is going to be less than or equal to 5. 5 is the cutoff. So look, temporarily, just for a moment, I'm going to put a vertical line at 5 to help me see. Okay, so here's a vertical line at 5. Okay, this vertical line is going to be my cutoff. Okay, so the top equation, the part I was just drawing, it's only going to be this one when the values are greater than 5. Okay, when the x values are greater than 5. So that's going to be to the right. So I'm going to put an open circle on that dot. That's the one right at 5. Greater than 5 is to the right. So that's why I'm going to draw this part of the graph in, the part that's to the right. So remember, don't think up and down, think left and right. Greater than is to the right. Any questions on how I drew the first part of my piecewise function? Yes?
How do you know when to do
Don't think up and down. Think left and right. Okay? Do you understand where all these dots came from? Okay. Okay. The 5, do you see this vertical line I put? How did I know to put the vertical line there? Okay, so you understand where the vertical line came from. Do you see all these dots I put? The first thing I had to do was graph the line y equals negative x. So it's where I'm picking the dot where the vertical line hit. Okay. Okay. If you understand that I'm going to erase all these extra dots now. Can I erase the dots now?
Yeah.
Is everybody with me? Okay, so I can erase all these extra dots now. Okay? Now I'm going to do the other part. Did I color it yet? Oh, no, I'm drawing it now. Alright, so now I'm going to do the red part. Okay? So now I'm going to do the line y equals 2/5 x. Again, so Hunter, watch, that y-intercept again is going to be 0. Because it's just 2/5 x. There's no y-intercept, so that's a 0. But I'm going to go up 2 over 5. So that's up 2 over 5. Up 2 over 5. Continuing on the left, that's going to be down 2, back 5. Down 2, back 5. So you see those red dots, everybody? That's going to be my second line. Look for the red dot that's at the cutoff line. So this is the red dot where I'm going to begin, because it's at the cutoff. Then it's just a matter of, will I draw the left side or the right side? Well, this time it is less than or equal to 5. That means I need to draw in the left side. Okay, so that tells me I need to draw the red part over here. Remember, if I made a mistake and drew the right-hand side, it would fail the vertical line test. Make sure all of your graphs pass the vertical line test. If you have both arms pointing in the same direction, that's not a function. It fails the vertical line test if they both point the same way. Just make sure that doesn't happen. So that's it. That's how you graph it. Of course, I'm going to go back and erase this vertical line that I put. Come on, vertical line. Maybe I got to do it like this. Yeah. Whoa. Okay. Blink. All right, that's how you do number 3. Any questions on number 3? Everybody's paper should look like that. Make sure you erase all your extra dots and any lines that you put that are not part of the solution. You erase them. Kayla. All right, number 4. Number 4. These are all going to be, I got to erase some of this. These are all going to be little horizontal lines, yes? Okay? For example, this first one, y equals 2. That would be a horizontal line at 2, like this. Okay? A horizontal line at 2. But we're going to draw the part of the graph where the x values are greater than or equal to -1. So, here's the dot that's right at -1. Greater than or equal to is to the right. So I'm going to start at this dot and I'm going to go to the right. Did I lose anybody just then? Hunter, is this making sense? Okay. Burton's here, y'all. What's up? All right, look at the next one. Let's see. Let's do green on this one. This one is y equals 3. So that's a horizontal line at 3. So that's like in this area right here. Okay? But I'm going to do the part that is between. And when you see a compound inequality like this, I want you to think the word between. We're going to draw the part that's between -2 and -1. So let's see. Here's -2. Oh, this is going to be really small. I better zoom in. Okay. I need the part that's between -2, which is right here, and -1, which is right here. Alright, so this is a really, really tiny segment. Alright, that's it. Do you understand why I'm leaving both of those as open circles? Why do they both get left as open circles? Nobody knows? It's a mystery? Yeah, look at the symbols. Less than, no equal to. Both empty, no equal to. Okay? Now let's do the last piece. Alright, y equals -4. I'm graphing this piece now. Again, y equals -4 is going to be a horizontal line at -4. Like so. Okay, so we're looking in this area. Oh wait, I should erase those extra marks. Okay, so now we're looking at a horizontal line at -4. But we're going to only draw the part where the x values are less than or equal to -2. And of course, less than tells us to the left. To the left. Starting at -2. Okay, so here's starting at -2. I'll put a dot right there. And then I will draw the part that goes to the left. Okay? So this is what your graph should look like for problem number 2. Any questions on that? Anybody lost? Okay. Let me zoom back out. Oh, yeah, that was problem number 4. Alright, so now we're on the back. This is really nothing new. I'm just showing you one other technique that you can use. It's up to you. Some of you, this will make more sense to you and you're going to want to use it. Some of you will be like, nah, I like the other way better. I don't care which way you do it. Okay, so I always do the left side first. I just like to work from left to right. I know that this is the left side because it's less than. So this is the left side. I'm even going to write the word left next to it too much. So I'm going to start by graphing this line. Now I'm going to use the new technique though. I should probably back up a little. The new technique involves you making a table of values, which I can use a calculator to help me. Okay? Now look, see this empty space I put in the middle of my chart? That's to help you see the break. This empty space represents the transition between the left branch and the right branch. Okay? So these values up here at the top, in fact, let me make this a different color. No, blue is going to be the other side. Let's make it green because that's kind of neutral. Okay. Okay, so look, so these values at the top of my graph, these are going to be from the left side of my equation. Because these are the, why did I put an F first? I don't know. These values will be the left side. Alright, those are the lesser numbers. That's how I know this is the left side. Now look, focus on this -1. See how I'm sort of beginning with negative 1 here at the break? I begin at the negative 1. Looking at the equation, can you see where I might have gotten that negative 1 from? Yeah, see the if part? If x is greater than or equal to negative 1, x is less than negative 1. That negative 1 is the cutoff value. If you're going to use the table of values method, the table has to split at negative 1. Okay, that value, the cutoff value, will always show up twice on your table. Once before the break and then again after the break. So we could use our calculator. Ready? Get your TI-30. Let's just put in 2x plus 3. No. We're doing the red one. So let's put negative 3x plus 1 in the calculator. And the table. Negative 3x plus 1. So here we go. Hit table. And we'll type in negative, what was it, 3x plus 1? Okay, so we'll type in negative 3x plus 1 and hit enter a few times till we get to the table. Now let me look back again. Notice, for this red part, I want negative 3, negative 2, and negative 1. So scroll your table to make sure you see negative 3, negative 2, and negative 1 x values. So these are the y values I need. 10, 7, 4. All right, Siobhan is about to add those to her table now. 10, 7, 4.
I got 10, 13, 16.
Okay, where's...
Where'd you get 4 from? Scroll up once. That's all. That was 4.
It's off?
4. No, you're right, but you said 4 for some reason. Negative 1 is 4.
Negative 3x plus 1. Are you not getting these values?
I got this.
You're not getting these values, Sawyer?
I did it on throughout the front too.
Okay. So do you have this equation in your calculator, brother? Hit your table button.
Negative 3x plus 1?
Aren't you
Yeah.
supposed to enter that one for...
It matters.
I was going the wrong way.
Okay. Now, we're doing the left side, correct?
Yeah.
Okay. Now the left side,
You have it as...
look at these x values. Negative 3, negative 2, negative 1. Are these values less than negative 1 or are they greater than negative 1? So this is the less than side. So that is the left part of the picture. The other numbers that go negative 1 and then 0 and 1, those are the bigger numbers. So when I get to that side, this will be the right-hand side. Okay? So the smaller numbers will always be the left-hand side. Okay?
Wait, can you graph it?
I definitely got to graph it. So, yeah.
Less than 4. The negative 1 value is 4.
The negative 1 value is 4. Hold on.
True.
Oh, yeah. 10, 7, 4. I just wasn't finished drawing it. Yeah. 10, 7, 4. And Siobhan's head is down. Come on, kid. So let's start with the cutoff value, because that's going to be our first dot. Negative 1, comma 4. So negative 1, comma 4 is going to be right here. I'm going to make it an open circle because it does not have an or equal to part on this. That's my beginning. Then I'm going to have negative 2, 7. Negative 2, 7 would be right here. Then I'm going to have negative 3, 10. Negative 3, 10 would be right here. Okay, so that shows me where to draw this piece. Okay, so that piece goes like that. Now I'm going to do the other piece. 2x plus 3. So I go to my calculator and I put 2x plus 3.
When you thought you filled it? No.
The part I just did?
Oh, yeah, we're good. I'm going to stop talking.
No, you keep talking, sweetie. If you have a question, you don't hesitate.
You
If I put in 2x plus 3 and hit enter a few times, now let me look back and make sure I'm getting the correct values. I need the -1, the 0, and the 1 now. All right, let me switch over to blue. So now I'm doing the right-hand side of the graph. So I'm going to put that in blue. I always do the right-hand side in blue for some reason. So -1, 0, and 1. So I'm going to scroll to see that. 1, 3, 5. Begin with the cutoff value of -1. So I've got -1, comma 1. So -1, comma 1 will be right here. It will be a closed-in circle. And then 0, comma 3. And then 1, comma 5. And I could repeat that pattern. I could continue. The same pattern goes on like this. Maurice, please stop talking. Continue to be silent then. Okay? So that's what this graph should look like. Any questions about it? I could do the domain and range very easily. Of course, the domain is -infinity to +infinity. What about the range? Look at the y value. 1, okay, because it's above, right? So the y value is going to be +1 to infinity, correct?
Yeah. And wait, why does it have
Oh, because see how this is a filled-in circle
Yeah.
at the +1? That means that's included in the set.
Okay.
If this had been an open circle down here, I would have to make it round, correct? All right, so that's example 1. Let's do example 2 now. All right, question, Siobhan? How are we doing?
I'm so good at it.
Excellent. Now, again, focus on the gap in my table. See the 1s that are on either side of the gap? Do you see that those 1s are coming from the cutoff number over here in the equation? Less than 1, greater than 1. That's why you put 1 on either side of the break. And then you go below that and above that. Now, Ashlyn, on the table, always, 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 the top of your graph, the top of your chart, these numbers are always smaller. So that means this is always going to be the left side. Okay? The bottom part of your graph, those numbers are always bigger. So that will always be the right side. Okay? And I always like to do the left side first. So, Ashlyn, can you tell me which one of these equations, the top one or the bottom one, will be the left side? The top one will be the left side. How did you know that so easily? Because the less than sign tells us this is the left side. So I'm going to graph this part first. Okay. So I put x minus 4 in my calculator. X minus 4. Okay, now I'll just make sure I'm looking at the correct values. I want it to be -1, 0, and 1. And that's what I have. So I will have -5, -4, -3. So put that down. -5, -4, -3. Start with your cutoff value. Start with 1, -3. So 1, -3 is going to be right here. It is going to be an open circle. Notice it is not or equal to. That's why it's open. Now I'll do the rest. 0, -4. 0, -4. -1, -5. -1, -5. And I can see this pattern would continue from here like so. So this piece of the graph is going to look like this. Okay, so that's another method I could use. Finishing up with the right-hand side. This equation is 3x minus 6. So I'll just change my calculator to say 3x minus 6. I want the values to be 1, 2, 3. So I will scroll until it says 1, 2, 3. Negative 3, 0, and 3, correct.
They're on the same point. They're cut off.
Then they will wind up overfilling it. So negative 3, 0, and 3, I was told. Start with the 1 comma negative 3. Now notice, 1 comma negative 3 is in the same spot. Do not try to make it look like it's both filled in and not filled in at the same time. If you fill in a spot that was empty, guess what? Now it's filled. It's just plain filled now. So we will just take this and fill it on in completely. Completely filled in now. And then I will do the rest. 2 comma 0 is right here. And then 3 comma 3 is right here. And then I can see the pattern, so I'm going to continue my pattern. Okay, so I could draw the rest of this like this. And that's what it should look like. Alright, it's time to pack up. Notice the domain and range are the same. They're both negative infinity to positive infinity.